Okay, guys, so we are live and welcome back to this very session. Okay, so briefly before we dive into the slide that we have for today, let's explain the project that we've done so far. That is this C project that was released yesterday. Let us go into it and then let's break down every of the resources that was given. Uh, I'm gonna be fast I'm gonna be fast, strategically fast. So probably we have question. You want me to pause and you want me to slow down? You can just quickly just you know just notify me. So as I said, you see, every of the resources that they release, it is necessary for us to go through the resources even if you don't get everything 100%, just make sure that you see them. Okay, I think that's the best word. Make sure you see them, they see you, you see the terms. Don't allow any time to pass you by, because you really we are going to really need it for future projects and also for understanding, as long as you want go through them again. That is where repetition becomes powerful in programming. Repetition is very powerful. The more you repeat, the more you do it again and again, the more it sinks, no matter how hard the concept may be. So every resources that is here, but some of them they are the same thing but in different formats, like some videos, some and so on. Now you see this this portion, every portion that they will always, every of the portion that they are going to instruct, that we should always check the manual. It is necessary we check too. Sometimes this thing might not be interesting because just a new world environment, lot of stuff to take in, and you might not really understand. Just read it. Sometimes you just read it through and just make sure that you just get every information to yourself. So now, one of the things I want to always call our attention to, but sometimes we get to the project, we just go to the project directly and we start working on the project, and sometimes we get stuck and we try to see some things and we be like, what is this, where did it come from? So what is necessary that we should always follow from here, this every point on this general going down to requirements, is very necessary that we make sure we check every of the details there, because those are like the guide to doing the project properly, and most importantly to avoiding lot of checker errors and issues and so on. you know so all of the general distance there, and the requirement here. Now, not wasting time, let's talk about the requirement. So okay, let's start from the general. I'll just read through. Why is C programming awesome? Who invented C? Who are Dennis Ritchie and all that? What happens when you type GCC main.c? Also, what happens when you type GCC main.c? An executable file is what's generated. Okay, what happens first? GCC is a compiler which what compiles is a compiler for C language, programming language, compiler for C++. It's the same, most widely used compiler for Objective C, Rust, and other programming language like that. So this is the syntax to using the compiler, GCC compiler. You write the compiler and then the file you want to compile. Ordinarily, the GCC compiler itself, it has lot of options that you can check from. When you check the manual, if I do my GCC, I will see every of the available options in the documentation on how I can use it. If you check out the synopsis, you can see every of the flag, that is the options available, and all of these options are actually what they are actually explained if you check through the manual down. Sometimes again, how do you make use of a manual? So probably you are looking for a particular thing. It's always good. I like to use the web manual other than using the terminal manual sometimes. So you can, as I am on the web manual, you can quickly just do Control F to find for something. Probably I want to find Intel, like a project that has to do with Intel. So every of the what searches that has that every of the searches that matches Intel is going to be given. So I have to what check if it is what I am looking for, as I check and check till I get to probably the information I am looking for. Probably Intel is not a good search. I can search for something else. Just ensure. Okay, let's say I search for assembly. Can you see now? This is a flag that that is telling me flag hyphen masm with dialect. It's saying it outputs assembly instructions using selected dialects. Okay, we are coming down to this place. There's a project that actually this is the answer to it, like part of the answer to it on what to do. So I'm just trying to tell us how you can strategically use the manual. Sometimes you just need to just search for a keyword that matches what you are looking for. You can see compile. If you say compile or link or linking, something that has to just do what you're looking for. So now what we are talking about here, the compiler GCC, how is it being used? You can use it like doing GCC. For example, if you do GCC, you can have as many options that you want to. Probably hyphen O, hyphen S, hyphen E, hyphen what again? Hyphen C, and so on. Or you are run to based on whatever you want to compile and the output you want to generate, and then the name of the file.c. Now, ordinarily, technically, when you run like this, it is going to compile your C file and follow. It is going to compile it completely, following through the four stages of compilation, where you have the assembly, um, where you have the preprocessing, you have the compilation, assembly, and linking. When you use it like this, it is going to compile it directly, completely, and then it is going to generate an executable file, which is what, if you don't name it, it's going to give you a.out. Okay, that is the name of the executable file it's going to generate. So sometimes if I say I want to compile this file gcc file.c, and I want it to have the name, that is, instead of it generating a.out for me as my file, as the output file or the executable file, I want it to have the name file. So when you add the flag gcc file.c and you add the flag minus o or hyphen o as output, and you give the file name file, something like this, or my code. That is, when this man runs through this program, this C program, it is going to generate an executable and give it the name my code. So all of these basic things are actually what they really want us to understand regarding this Hello World and this first project on the intranet. So when we get there, we'll actually see each of the projects explained. So what is an entry point? The entry point is always the main. The main function is always the entry point for every C program, where you start writing your code, where you start writing your program. Just like when we did our last lab, we explained the structure of the C. So how to print a text using printf, put and put car. When that was like part of the general thing that they want us to understand. how to get the size of a specific type using the unary operator size of. Okay, so size of is an operator, and what type of operator is it? It is a unary operator, that is an operator that receive just one operand. Under the um slide I created here, part of the thing we are going to look at when we get to when we get to type of operators in C. Okay, there are basically two types of operators in C, which we have. Okay, there are basically three operators in C, sorry: unary operator, binary operator, and ternary operator. I know that when they released today's project, they were talking about different operator. You have seen something like arithmetic operator, relational operator, um, uh, logical operator, and so on like that. But every of the operator they fall under these three categories. So one thing that makes that will make all of this thing interesting is understanding every bit of the concept, where they come from, such that when you see them, you already know what it means, and then the logical aspect for you to now create your program or to solve a problem will be easier for us. So, for example, when you talk about English language, I'm talking about write a formal letter to somebody. Understanding what a formal letter is the first step that will really help somebody to know what are the contents that will be inside the letter. So understanding what these terms mean. So that is what they are trying to talk about here, where we see printing or getting the size of a specific type using unary operator size of, how to compile using GCC. As we said here, you can compile using GCC, you can compile using different option, applying the options to it. Probably you need only the assembly code of that file, or probably you need only the you need it to compile, but it should not link, or probably you need it to compile and generate the pre-processing code format for you, all of this flag. And also when you are compiling, to understanding some of the error checkers that are what associated with the GCC compiler. Okay, so all these things are there in this very project if we look closely to every of the concept bit by bit. So now we see another, what is the default program name when compiling with GCC? I said it that if you do not specify a program name for your compiler when you are using GCC to compile your file, if you fail to specify an output name for it, just like doing GCC file, if you fail to use this output option with the file name, it is going to generate an automatic executable file for you with an automatic name, which is always A. Okay, a dot out a dot exe. Okay, so what is the official C coding style, and how to check your code with Betty style. Betty is a linter, and we are being asked to install it. There is a way you can even check the Betty documentation and try to see, probably it is giving you error in a particular thing. You can really see what is there, or you can check how what are the style and what they really want you to write, so that you can follow the rule. How to find the right header to include in your source code when using a standard library function. Remember, when we're talking about our structure of a C program, we talk about the sections, group them into section, where we have the comment section, the header section. The header section is where you what impute every of your include files. Hash include whatever you want to include, the C library. Okay, so most of the C programs, they run on the C library to perform many of the function, many of the operations. So understanding what each of the library does too, somehow it helps. Understanding which library will be needed for mathematical operation and mathematical computations. Understanding which library will be necessary for me to create or work on strings, copy string from string, or get the length of a string, understanding what library will be needed for me to detect error, and so on like that. So how does the main function influence the return value of the program? What this one is saying is that, of course, every main function, the main function is the fundamental function in every program, C program, and it is the entry point for all of your program code, because if you really want your program code to run, they must be inside the body of the main function. So the main function is like the father and the mother of all your code. So now the main function has a return type, which is what? Int. A return type where you see always see int main. Okay, you can see it has a return type which is int. Okay, and for every return type, it must always return a value to show if the program is successful or the program has failed. And this is what they are trying to say, that how does the main function influence the return value of the program? It influences it, that is, if the program or if the main function or the program returns zero, it means the program ran successfully. If it returns any other number, it's there is an error somewhere. I just tried to explain all of this stuff that are tied up here. Now, requirements, Vim, VI, Emacs, all your files must be compiled on Ubuntu 20.04 LTS, GCC. And now, using this option, you can see the option where you have wall, Wero, Wextra, Pedantic. So this is what they are saying. That is, after running GCC, the name of your file, and probably the output name you want to give to your file, these error checkers for the compiler will be what? Will be attached, and they are necessary to check in some internal aspect of your code if you are violating the rule. So if you violate the rule, a compiler error will occur, or a compile error will occur. So all your files should end with a new line. As usual, readme at the repository. Now, all of this is not where we are going. Let us look at the first. I believe everybody understand how to run the dirty linter. So, I'm just trying to dive. Now, this first project, preprocessor. Now, he said write a script that runs a C file through the preprocessor and save the result into another file. Now, this this project, the lines, you need to really understand it so that you can know what it is saying. Now, a script that runs a C file through the preprocessor. Now, after it runs it through the preprocessor, it stops there. So that means you are not running the compiler fully on the program. You just want to get the preprocessor output of a typical C program. Now, there is something here. How does what are the well, talking about the compilation or execution process of a C program? Sorry, not a processor. Execution process of a C program. Now, if you look at this, I want to use this to explain that this thing. Now, if you look at this, when we run our source code, it's now it passes through this stage. Now, the name of our source code at this point is first.c. Let's assume the name of the program is first.c. Now, it passes through this stage. It goes down and enter through the preprocessor. Now, some operations are performed to it as the compiler runs on first.c, and an output is generated. Let's assume that output is first.I. Now remember the source code, the C source code undergoes four stages of compilation, which is one, preprocessor, two, compile, three, assembly, and four, linking, before it now generates the output. That is the executable file. Now, when it runs through the preprocessor, there is what? Something is being done, an operation is performed on the code, and an output at that point is generated, which is we call first.I. After that, it passed through what? The compile stage. Now, something happens at the what? At the preprocessor stage, which is what? This something like this. Example is every of the header files are replaced and macros are expanded. You know, when we were talking about structure of the C program, we talk about um, definition section, and that is where we add something like a macro where we say hash define, blah blah blah, and so on. Hash define. So every at the preprocessor stage, your header files are what? They are replaced into actual functions, and all the macros are expanded. They are being executed. That is what happened at this preprocessor stage. After it passed through that stage, it generates this it generates this extension first.I, pass through, enter through the compile stage, and at the compile stage something is being done. And what is being done at the compile stage? This is where you see where there's a check by the compiler checking for syntax. If there are syntax error, if there are no syntax error, you know, if there are syntax error, it will check, and if there are errors, it will what? It will bring out the error, and it will tell you that you have to check, fix the error, and we compile, going back to what? The beginning. This will be yes if there are what? Syntax error. So if there are no syntax error, it will go down, and at this point it generates an assembly um, code. That is where you come down. You see, it will have first dot assembly ass, and what? It goes to the assembler to assemble it into an object file. And after it passed through the assembler, it goes and link. It links with what? The system libraries, and that is where the executable what file is being what generated. Now, what we need to understand here is that at every point of execution, preprocessor, if you run the GCC and you want it to stop at the preprocessor stage, there is a flag that what is used to make it what stop at the preprocessor stage. If you want it to stop at the compile stage alone to generate uh to just compile but not link. When it compiles, it does not link. There is a flag that you need to what make use of. If you want to generate the assembly code, there is a flag that works for that, GCCS. And when it does the overall execution to this point, then it is just GCC without any of the flag. So what really matters is that we understand every of this process of execution by the compiler. And that is what they want us to achieve. Now, solving this problem here. Now, firstly, we need to know that we are writing a script. So I know that I'm writing a script now. I'm not writing a C program. So, and that script is going to do this instruction. It's going to run through a C file, and it is going to stop at the preprocessor stage, the preprocessing stage, and it is going to save the result into another file. So now, Firstly, we need to know where the C file is going to be, and secondly, we need to know the output, where it is going to save the result into. That is where you see these two bullet points. The C file name will be saved in the variable, that is the C file that the compiler is going to run upon, is going to be saved inside this variable called C file. After that, when you run it, the output should be stored inside a file called C, such that when you run the script and it runs through the C file and it stops at the preprocessor stage, it is going to save the output, generate an output called C. That is what they are talking about. So you can see that every of the lessons and projects we'll be doing in ALX, they are integration of step into step that will make us perform project into project. Because before this time, we've already learned about shell variables, how to create variables in shell, and how to export the variables. So technically, if I'm to attempt this project, what am I going to do? What I need to do is I firstly I'm creating a script. So that script needs to have a name, and that is what they have given us here. The name of the script is zero preprocessor. So I have I have it already. If I I just want to go through because we don't really have time. So let's just assume we are. So this is the file that I'm writing the script. So normally we understand that writing a script in shell, you use the hash bang syntax. It must be at the top to what, to make it a script. And now the actual code that is going to do the what, the compilation to stopping at the preprocessor stage, is what is going to be inside this man. And that is the second line that I'm having here, which is, if I explain like this, the compiler GCC, and it should what, compile the file C file, but the file is a variable file. That is why it is having this dollar sign C file. Now it should not do a complete compilation, but it should stop at the preprocessor stage, which is what, having this flag -e. Now um I sent a material to the group the other time, which it actually just emphasized on, where is it? Okay, let me just check. Sorry. No. Okay, this. Now, if you watch, this is actually output controlling the kind of output on the GCC. Is a GCC manual, gcc.gnu.org. Now, there's a portion I'm actually looking for. Pre-processing. Let me just search. Pre-process. Okay, I think this is what I'm looking for. Now, look at from this flag here, from this point, this very point. It talks about all the flag. This E, he said it stop after the preprocessing stage. Do not, it is telling the compiler stop after the preprocessing stage. Do not run the compiler proper way, in the proper way. The output is in the form of the preprocess source code, which is sent to the standard output. Okay, let's just, I think this is what we need. It should stop at the preprocessing stage. That is what this flag does. So that is why I said most of the answer is actually based on reading the manual. So that is why we added this flag here. That is GCC compile this C file, but stop at the preprocessing stage with this flag, and generate the output but store the output inside C. So it is going to create a file and then store the output inside C as the file. So this is what this script is going to do, and that is what is needed. If I clear now, the next thing now is what? That is one step. The next thing is that we need to understand that there is a C file that we have to create. This variable. So that is why, if you look at the example they gave here, they did something, they previewed the value in the content inside main.c, and it generated this man here, okay, which is the actual template, acceptable template by Betty for every of your C programs that we are going to write. The comment section, the main function, and the return value. So technically looking at this, that means the actual C file that they want us to create should be main.c. That means we need to what? Create a file called vi main.c. We need to create a file called main.c, and it is going to include or contain, you can see, it's going to contain what is here as it is, starting from hash include as it is, the template, down to the comment section and the main function. So now, as this part is settled, the next thing is to make sure that what is to now save this the main.c file that we created, saving it inside the C file. And that is where the concept of shell variables comes in, and assigning value or storing value into the shell variable. So this option here, they've even given us an hint that if we want to save the C file, main.c, inside C file, this is just what we need to run. Export C file, this variable called C file, and assign it to main.c as what we need. So I can say I copy it, or I can type it myself. Export C file and set it to main.c. So obviously, if we check back the step, we need to make sure we know what we are doing. If we check into the script that we created initially, that is vi preprocessor preprocessor, you could see that it is a script, but the script is going to perform this action. The compiler will run on this variable C file. So now compiler is not interested in this man here, C file. All this compiler is looking for, what will give this compiler power to work? It must look for something or any file name that ends with the extension .c. So what we did from here is that we have saved the actual C file, which is main.c, and we have set it and saved it inside this variable C file. So compiler will run like this: gcc, okay, I'm stopping at the preprocessor stage. Where is the file? Is this guy? I don't know this guy. Okay, it is a variable. Okay, it is now going to look into the variable, what is stored inside, and what is it going to look for? Anything that has the extension .c, it will what? Run through it and stop at the preprocessor stage according to the instruction. Now it will now check for further, is there a particular name they want me to give to the file, and that is where it looks for this flag hyphen o, which is for output file name. If it checks it and it sees it there, okay, the user has instructed me to give it a particular name. So what is the name? C. So that is just the basic way to explain what the everything that is happening here. it is looking inside this variable and searching for any file having the extension .c. So after it has finished that, it is going to what? Execute it accordingly, and it will generate the C file. Now, if I run the script, I can run the script. Before I run the script, I've already turned it to a executable from here. I ought to run the chmod option on it to add execute permission to it. Okay. So if I do chmod u.x 0 processor, it is going to add execute permission to the file, which is to be what in this color green, as based on based on the shell. So I can now run the script. Our normal way to run the script, we have passed through that stage. So ./0 processor, and the output it should generate for me should be C, and you could see C. Now let me do something. I'm going to clear the screen. I'm going to ls. I'm going to remove the C file, the output. I'm going to clear. I'm going to ls now, and you can see there is no C, any file called C there. Now, if I run the preprocessor now, if I run the script and I ls, the output has been generated, which is this file. And the that is what this program is all about. This task it wants us to achieve. Remember, instruction, it is a script. That is why we run it that way, using /script name. And of course, we've added execute permission to it, and it is going to what? Run through a C file. And that C file is stored inside the variable, this variable. So that is just the basic understanding of this number one project. Number two project is similar to it. It is going to create a script that compiles a C file but does not link. It is as if we are repeating the normal step that we had as we have it inside this preprocessor, blah blah blah, preprocessor. It is going to run as if it's going to be like this, but something is going to change because this one is going to stop at preprocessing stage, but this one is going to compile. It is going to make sure that it compiles but it does not link. So now we need to now look for how are we going to do this? How are we going to, what option are we going to add to the compiler such that it will compile a C file but it will not link? And that is when we need to go back to the manual and check what is there. So coming to the manual, if you look at the option, this C option is saying it is going to compile or assemble the source file but do not link. That is with the -c flag. So obviously, all I'm going to do is to replace -e with -c in that if I'm to get the answer for this ask one. This is, I'm going to replace it with -c. Let me enter into the file. I'm going to stop. I'm not going to run through. I'm just going to give an overview, and I believe you understand. So just like this. So further looking into the instruction, it said the C file name will be saved in the variable C file, just like the previous step. That is main.s, we're going to be stored inside here. And now it's saying the output file should be named as should be named the same as the C file, but the extension .0, but with the extension .0, that is, the output should be the same name as the C file, but it will have a different extension. And I give an example. If the C file is main.c and we run the compiler to it such that it compiles but does not link, the output should be main.o, main.o. And automatically there's something that will happen here. If you look at the flag from the documentation, it is saying it will compile or assemble the source file, but it will not link. Now it's saying the linking stage simply is not done. The ultimate output is in the form of an object file for each source file. It is now saying now this side is where we need. It said by default, the output that it generates, that is the object file name for the source file, the object file name that it generates after it has compiled but it does not link, that is the source file, is made by replacing this suffix. That is, by default, automatically it is going to replace the extension from the source file, which is .c or .i or .s, whatever it is going to replace it automatically with .o. So automatically running the compiler with this extension, it is going to automatically replace the extension with this. Running the compiler with this option, it is going to replace the extension of the source file from .c. It is going to replace it with .o automatically. So normally it is going to replace it from, probably the name of the file is main.c. It is going to automatically change it to main.o. That is why we didn't specify probably an output name here, like probably output, adding the flag, probably adding the flag like main.o. No, automatically it will be done. That is about this one, compiler. And of course you do your addition of your stuff and all that. And of course, in fact, the single export that you did in the first place, export C file equals main.c, that you did in the first place, is what work for every of your projects, so that you don't need to be exporting any this one again and again and again. And there's a trick if you want to check or see or view your variable that you create, that is, if you want to check the C file, if it has been created and seeing the value, you can just do set and pipe it into less, or you can run only set, but I want to pipe it into less so I can see it in a paginated format. So if I say set and I pipe into less, I can see every of the variable environments, every of the variable in the shell environment, and I can search by using / file name I'm looking for. So C file, and what give me the name of the files. It will show me if it exists. C file. So guys, that is about that tax. Now, if I say a tag that is similar, I'm going to skip it because now it said write a script that generates the assembly code of a C code and save it in an output file. Now the C file name will be saved in the variable just like the previous step, but the output file should be named the same as the C file. Okay, so but this time with the extension .s. Just like the other one, the extension was .o, but this time .s. Now it said example, if the C file name is main.c, the output should be main.s, and that is what they are talking about. So that is needed here, what is needed here is that we need to look for the flag on the compiler that will generate only assembly code. Going back to our manual, you see, if you look at this flag -s, it said it is going to stop after the stage of compilation proper. It is not going to assemble. This is the output in is in the form of an assembly code file. So this is just what we need. It's saying it's going to what generate assembly code. So the output is in the form of an assembly code file. So it's going to generate assembly code for each non-assembly input specified. So now it's not going to say by default automatically the assembler file name for a source file is made automatically, and it is going to replace the extension from the source file .c with .s. So running that, if you look at this man here, that is number what? That is number two. If I say vi2 assembler, of course, this is what it means. GCC with the flag minus s or hyphen s, and then the variable file name, and it's going to generate the output according to the name of the source code, but with different extension. So, guys, this these are just what they really want to, aside the fact they are not providing everything to us, they're not giving us 100%, they want us to think. So there are some logical things that you really need to check. As an example, you need to see, like seeing that they did something like export c file equals main.c. You know that it was not specified here anything like main.c, that main.c, you know that you have to create a file called main.c. You are seeing that they are doing cat main.c here. You need to see the example and then understand that you have to create main.c and make sure that it has this content inside. And then you could see from here they were running the script, and when they ran the script they listed the files and they see automatically it generated the output. It was what it is being as expected. Looking at this one, he said write a script that compiles a C file and create an executable named C is fun. So automatically this one is going to compile proper without any flag. It is not going to stop at either preprocessing, it's not going to stop at compilation, it is not going to stop at assembly, it is not going to stop at linking. It is going to output a file, compile it proper, generate an executable. And they're now saying that you should make sure that the executable is going to generate is having the name C is fun. So this is number three. If I let me remove some files here, a.out and then it's fun. Okay, so if I vi3 name, which I've already done, you could see it is running through the still the same variable file that we created, but this time with the output file name should be C is fun, and as it is here. So that is basically what they are talking about. So it is not like GCC you add a flag to make it stop anywhere. It is not stopping. Run it, compile it proper, give it a name, C is fun. And now, if one thing that you need to understand is, let me go back and open it. If I fail to if I fail to give it this file name, and it we are this time around we are running it proper, compile proper without stopping anywhere. We are not stopping at processing or assembly or anything. We are running it. It's going to run the file completely. And now I did not specify. Let me copy it because I don't want to type anything again. So I did not specify the name of the file. I just I just did this. Now, if you run the script like this, I said it's going to generate an automatic file which is called a.out. If you look around here, there's no file called a.out. But when we ran the script, it generated an output called a.out. That is what they are talking about. So because of the fact that we did not name we did not give the compiler a name to name the compilation, the executable that is going to be created after compiling, the automatic name is going to generate is a.out unless we specify. So let me remove a.out and let me go back into the file. So if I vi3 name, no, that's the wrong name. If I vi3 name and I'm adding that flag now. So now I'm telling you that I should what? Give the output name to be C is fun. So if you go back and run dot forward slash, if I list file, you can see a file called C is fun should be created. And this is it here, C is fun. So that is just basically what they want us to achieve. Understanding how to use output, how to set your compiler to have a default output name, you know, and using the compiler with its option properly. Now look at this. He said write a C program that prints exactly. Programming is like building a multilingual puzzle followed by a new line. Now they are saying you should use function called puts. You are not allowed to use printf. Your program should end with the value 0. Now look at the example. They ran the compiler with the error flags, that is hyphen wall, hyphen wero, workstra, pedantic, std, gnu 89, and then the name of the file, which is put, this file, put.c, and then they ran the file itself. The automatic file that was generated was a.out automatically, and what they are expecting that the result that we have should be this. And after that, this command is used for checking the error value of the state of a particular command that is being run. If there's an error, if there's no error. Now the value that is that was generated here means 0, which means it ran successfully. When you run echo dollar sign question mark, it is going to generate the command value or the state of the command that you ran, if it is successful or not. If I do something like lls here, okay, if I do something like this, lls, there's nothing like that. It's saying command not found. Now if I check the state of this command, my last command, it's giving me what? 127, because an error occurred here. But if I clear and I do ls and I do echo dollar sign question mark, it's going to give me error, I mean 0, telling me that there is no error anywhere. My program ran successfully, or my command ran successfully, or the action I took on this environment went successfully. Now um this one is technical a bit because you have to pay attention to detail. The program should print exactly. Quotation programming is like building a multilingual puzzle. That is what they meant. It is not like it should print exactly, you now copy from here or you start from here. It should have both the quotation. Now, if I VI, I'm not going to start all of that because now this time another thing to pay attention to, you are writing an actual C program now. You are not writing a script. Hello? Okay, sorry. You are not writing a
Hi.
script. At this point, you are not writing a script, you are writing an actual C program. And they are very, very, should I say wicked or no, they are not wicked. They are technical here and expecting that you know what you are doing. There was no option like if you look back here, you could see something like you could see this. Nothing like that is here. Is at that number 4. What is there is that they are expecting you to know that you are writing an actual C program, and you should know the structure of how a C program is going to be, and it should follow the Betty's rule and style, and so on. So now we have what? The name of the file. Even from the name of the file, you know that this is not a script, it is an actual C program. You have 4-put.c, of course, an actual C program. And now they're now telling you that it is a C program. In fact, from here already, even if you missed this and you didn't see that, it said write a C program that prints exactly this, followed by a new line. And you are being told to use the function puts. So there's a function called puts. You are not allowed to use printf because of course we know printf can print to the standard output too. But we are not telling you to use printf this time around. You should use put instead. Your program should end with 0 after you run it, just like the example they did here. They compiled it and ran the output at the same time using this AND operator. When we get to operator, you see this thing will become clearer to you and you understand why probably you have observed and you see that they add something like this. You'll be trying to look at why is it there, what are they doing here. So now they ran the program gcc with all of the error flag and the name of the actual C file. They didn't specify an output name. That is why this what a.out was generated automatically. And now after running it, they make sure that they what run the generated file too so that it can print to the screen, which made it to print this man here. So using the put function, and it should print this string followed by a new line. Now there is now something to do as the very first thing. It's not able to run and start doing the code. The first thing is trying to understand how the put function work, because at the long run we already understand how the structure of a C file is going to be. So we know that okay, if I open this man, if I vi for hyphen puts, I know that I will do hash include comments and then main function. Good. But now the actual program to execute is to use put to print this value. So I'm not familiar with put before. I need to know what put is. So the best thing is to read the manual about the put file, which I can do on my terminal. I can do man puts. You see, I can do man put and the manner of what put to be generated, which is put and Linux Programmer's Manual. And it has alternative name. You have F put C, F put C, put car, puts itself, which means output of characters and strings. And you have the synopsis. It must always what the standard input and output header file must be there in order for it to function. Because now a quick crash course on hash include stdio. This man is an header file which is used as it is needed for in order for us to it is needed if we want to write a program that is going to print something to the output screen, or it is also needed if we need to receive input from user. So hash include stdio is needed for printing to this out to the screen and receiving input. So like it is needed for input and output operations. So .h header. So all of these are just synopsis of how you can use it. Okay. Now description. This is for f put, not what we are looking for. The description that's what that that corresponds to puts. When you open a manual, you don't have time to read the manual completely unless you want to dedicate time to study a manual. So what we need is manual for for puts, and it says put. What does it do? It writes the string s, or it writes a string, okay, and a training new line to standard output. What does this English mean? That put is used for printing string to the standard output, and it's what it will always return a new line. That is just what they mean. So sometimes when you look at this question, uh, at first that you look at this question, you will be like, you are actually printing this string, good, using puts, okay, and now it's now saying followed by a new line. You now be wondering, how are you going to write a new line using the put function? But following the manual here, it is automatic when you use the put for it to print a new a new line. So that is as simple to understand. as it is. Sometimes one thing that I'm always not happy with programming language, even at this point when I started programming language, sometimes the English they use sometimes is problematic. Sometimes if they had used something,
Very, very.
if they had used simple English, it would have been easier for somebody to understand. So there is a barrier in, and why they are doing it, they are using more technical language. So I think that is just it. So and now
That was
what we
where I
can
was having issues when I was solving this particular number four, because I saw followed by a new line. So I added the backslash n. So I started getting
exact
error. Later when I now
exactly
checked manual, I realized that it naturally prints a new line.
a new line. So if I vi the four.put file, I'm not going to start doing it from 13. Look at this is my file. I have I have the hash include, I have my comments, and your comments could differ from anybody. I have the main function. I make sure that I do it in a way that is acceptable by Betsy. Sometimes everybody is sticking to main entry and probably the variables declarations or parameters and then description, and that's all. But look at if you can see my own here, I added author, even I didn't spell it well sef. I added author there, as long as I follow the rule given by Betty. So going to the program itself, you can see puts and exactly the string they asked us to print, which we have here. You could see normally if I copy the string that was given and I paste and I type it like this, there will be an error because you are using quotation inside quotation. I mean, you are using the double quotation inside a double quotation. So we have learned all of these things before now because we are operating in the shell environment and the C itself is similar the way the shell operates. So we need to escape it using the backslash. And that is what it is going to print this value exactly as it is, and because it is put, the put we add a new line automatically, and this is the expected output that we are supposed to the expected way to solve the problem. And oh sorry, so as it is, that is for that one. In fact, this is the level of, I don't know guys, this class probably I'm going to continue, and anybody that wants to go off will go. I'm going to cover something. Anybody that can stay should stay. It's going to be a long class. We still have our slide. We've not done our slide. There is something I really want us to touch this slide, touch some concept here. It will help us. It will build some foundation, especially for the if else variables, whatever that project that they are giving to us. It will help us to understand very well with practicals, and when they come, you at least you will be confident enough to fight ALX, not ALX fighting you this time. Um, Number five, he said write a C program that prints exactly. Okay, sorry, that's four. That prints exactly this this string. That is with proper grammar, comma, but the outcome is a piece of heart, comma. You can see, followed by a new line. And this time around, you have to use the printf
Printed.
function. Now, you said you are not allowed to use the put function, of course, and your program should return zero. That is when you run this echo dollar blah blah blah. Your program should compile without warning when you use wall gcc. That is all that I was saying here, this extra option you can see, and the actual name of the C file. So we are already writing C program. You're already a C program already. You are writing C. So what is the program? What is it going to do? It's going to print exactly this, and it's going to do that using printf. So if I'm new to printf for the first time, one thing I'll be curious about is followed by a new line. How do I add a new line to printf function? And that is where you will now still do your man printf, and then you can see printf as the name, format and print data. Normally, generally, printf is a function that is used for printing, formatting, formatted output. Or how will I say it again? Printf is a function for printing formatted output. When you say formatted output, that English, it means an output with specific way it should what? It should be displayed. I don't know if that English is better. An output with specific way you have specified it to look like. Okay. An output with a specified look, an output with specified display. I don't really know. Just understand what format is. So you actually shape it, customize it to your own taste, to the way you want it to look like. So we have the printf format. Then you see printf, the synopsis, printf, the format you want, and the argument. So printf prints is used for printing strings of characters that is enclosed in double quotes. In our last class, previous class, we talked about difference from a string and a character. When a string use is enclosed in double quotes, character is enclosed in single quotes, So when you want to escape all of this, you escaping a double quote, escaping a backslash, adding an alert to your this thing, adding a backspace, um new line. This is what we are looking for. So forward slash n. We know it, or probably let me don't assume anybody knows. So I'm just giving us some of the steps. So we already know that we are doing printf in quotation mark forward slash n to give us to print a new line. So we can always now put a string of character inside here as we use the printf. Okay, so just like this. So saying printf a string of character, and that is how we use the printf. So if I open my solution, I'm going to be fast now so that we can just touch. If I say 5 vi5 print f.c, you could see just as it is. Your normal, this one now will always be here as usual. Now int main void printf with proper grammar as it is the text and a new line. Okay, now let me give us a tip, um, a trick, let me call it. For example, because project will come soon enough, and most of the time you always want to do, let me cut, let me cut 5 printf. So I'm not opening with I want to cut from here 5 printf. Let's see. So normally every of our program is going to be having hash include all of these. So sometimes it might look stressful. I don't know. I'm not trying to keep make us lazy, but sometimes when you are a super user and you don't really have time for all of this, and you already know an advanced way to use all of this stuff. You can always implement the advanced way as long as you know what you are doing. So every time hash include, come down, you type all of these, you type this one too, and then you start writing your code. It might be tedious and it might be time taking, and you might get stressed out, or sometimes you might want to enjoy it and really type and get familiar and so on and so forth. But if you really want to skip that step, you can just look for any of the file already, just like for example 5 print f.c. I can say 5 print f. Let me clear my screen. I can say 5 printf dot
Yes.
c. Okay, and probably the new file that I want to do my project on is my c file dot c. So all I want to do is I want to copy the content of 5.printf
Hmm.
dot c inside my c file. I'll just use the cp command. Eh? When I use the cp
Hmm.
command, everything inside here will be inside here, and I can just open this man and just edit where necessary and then do what I want to do. So if I enter, eh, and I clear, and I ls, and I vi my, what did I even name it, my c file dot c. Now it copied even the what, even the executable permission. It added it to, okay, you could see everything together. So if I open it now, vi my c file dot c, you can see this is what I opened, my c file dot c, and it has it there. So I can always come in and then probably, if it is not void or the description, I can then edit what is inside and make my life easier and faster. And then I can come to my code and start typing print a and so on. So that is just a trick I'm just trying to share with us. So now this one now I had an error that I never saw. I tried to check, and I was like, what is happening? And it was just a simple typo. It said, write a C program that prints the size of various types, that is various data type, on this computer. On the computer it is compiled and run on. You should produce the exact same output as in the example. Warnings are allowed, okay? They've already stated that your program should return 0. You might have to install the package lib6 minus dev minus hyphen 1386 on your Linux to test for M32 and M64 GCC when you are running GCC. So this one is very simple, it's not a problem. The first thing to even start as a step is, now, how do I print size of type on the computer? If you remember our last class, we talked about how you can view the various uh, data type that we have. When we listed the data types, and we mentioned something that is very, very, very important, that in C is very, very more concerned about what you are doing, and also the variables that you are using. It is always specific that you know why you are using that variable and what you are using that variable for. And there's another thing about C that we need to understand, that is that for every data type that you choose in C to store a particular variable or to store a value, that data type, it has a position or a location in the computer memory. One, it has a location in the computer memory, that is that variable with a particular data type. It has a location in the computer memory, and as it has a location in computer memory, it has a space, an amount of space it is occupying, and that amount of space is in bytes, byte, and byte is actually equal to 8 bits. So for every type of data that you are storing, probably an integer, probably a character, probably a float, whatever type it is. For example, I think this is a good example. Something like this. You see, int, character, float, double, whatever type you are printing, you need to ensure to know that they have different sizes that they occupy in the computer memory. int char float double. If I run this using a particular operator that made it to be possible, it is giving me the value size of an integer for character 1, float for double 8. So what they really want to achieve is now what we need. If we are solving this if you are solving this problem, one thing you need to now first understand is how am I going to what is the operator or what am I going to use in order for me to be able to print the various type. And that is where the size of operator comes from. So the size of operator, it is a unary operator which is used for printing the size of various types. So the size of operator is a unary operator. When you say unary operator, is an operator that performs its operation on an operand, a single operand, a single value. And he said the size of operator gives the amount of storage in bytes, just as I said, that is required to store an object of the type of the operand. So it gives the amount of space in bytes that is required to store an integer, a character, a long integer, a long integer, a float, a double, and so on. So understanding that size of operator is what we need. Next thing is probably you might want to install this using normal way to install packages on Linux is apt install then package name. Okay, so this very tool and then the name of the package that you are installing. So which is this guy. So I have it installed already. So like this, it will tell me that it is already installed. So now probably I'm running it on my Vagrant and I'm running it not as root. That is why this error is coming. Could not open log file, blah blah blah, permission denied. So if I do sudo apt install this man, you can see it went completely because I have it installed already. So I actually added the sudo to have root privileges. We already did that when we are talking about shell. I think we know what we are talking about. So if I open the file, okay, that's vi6 size, vi6 size.c. So this is what we have. So you can see the normal section and then the main file printf size of a char, and then the size of operator. Actually, this is the size of operator itself. So this is the string that is going to what we printed as according to what they said here. It should produce the same output because we were targeting this output size of, we want this output to be produced. So we should have size of a car, then colon, then the actual size. This one is what will be generated by the size of operator. So that is why we have size of a car, then the normally, if we are printing an integer, we'll be using the format specifier %d. But what we are using here is %lu, that is long unsigned int, or we can use %zu, which is unsigned int. Zu means unsigned int, and long u means long unsigned int. Any of the two can work for the size of operator, and it will print the size of the type or the data type accordingly. Okay, so if you look at what we have here, we follow this format: size of a car, colon, then this will give us the actual size. Then we move to what? Bytes. BYTE. And then according to this text, in parentheses s, that is if it is bytes, and then followed by a new line. There's no space in between. Now people are when people are having issue with this project, at some point they started with small letter s. It will detect, the checker will return an error. At some point probably they put a space in between the byte and this stuff here, the byte and a new line. It will return an error. Probably they put too much space in between here. Instead of single space, the checker will return an error. So when you put a new line, then you reference this percent %lu with the size of operator, and then you input the type. You are checking the size. You are trying to check the amount of size it is storing in this machine. So the same thing, making sure you follow the formats. And after you have successfully entered every of the type as given, you see long int. You make sure it is long int. And also at this point here, you can see long int. You are checking the size of long int. You are checking the size of long int, ordinary int, char, and float. After you are done, you are now what? Good to go. So testing your execution is when you now run this gcc, the c file, and m32. It should store the output as size 32, and if there are any error, send it to temp, that is these two redirection. If you try to, if you follow up with all the projects, the file decryptor where you have standard input, which is 0, standard output 1, and standard error 2. So this is saying compiler compile six size.c, and then we are checking for size of a particular type on a machine. So I'm trying to check for size of all the type that will be inside this C file. I'm trying to check for their size on a 32-bit machine, and then set the output to be size 32 for me. And if there are any error based on the syntax that is being used, probably they are supposed to use LU, they use ZU, or probably they are supposed to um, put a single space, they put double space or something. Send the error to temp. I don't want to see it. And what? It will generate this output size 32. And then the same thing for checking on a 64-bit machine, it will generate this output size 64. So if I list my file here and I remove size 32 and I remove size 64 at the same time, I clear the screen, and if I run this code, the if I run the sorry, if I run it, if I list file, I should see 32, size 32. I check forward size 32. It should give me my output, and it is going to give me the size of a car int long int long float based on a 32-bit machine. What is should be the actual value on a 32-bit machine? So sometimes we just need to also try to know this also, because when they start doing that quiz, they might be asking all of these questions. Or sometimes if they ask a question, you can just run this code on your computer to confirm. Or it's something that you can really cram. Size of a car is always 1 byte. This one does not change till eternity. And size of an int on a 32 bit is 4 bytes. On a long int on a 32 bit is 4 bytes. A long int is 8 bytes on a 32-bit machine. Float is 4 bytes on a 32-bit machine. Now when you run for 64 bits, it will give you the value 2 on a 64. So now I'm running the compiler now for it to generate size 64 for me. So if I run that size 64, I should see size 64, which is this man. So I can do dot / size 64. So you can see. So virtually it almost look the same thing. If you see, float is 4 bytes on a 32-bit machine is 4 by 2. Long int is 8 byte on a 32-bit machine, and on long int is 8 byte on a 64-bit machine, while it is 8 by 2 in a 32-bit machine. But long int is 8 bytes on a 64-bit machine. Long int is 4 bytes on a 64-bit machine. Int and int is 4 bytes on a 64-bit machine, and int is always 4 bytes in 32-bit machine, and char is always 1 byte no matter the type of machine being given. You see these bytes being 4, 1 and all that, they are as they are like this. When you have char, int, long, float, they are all called signed. They are all signed. They are all signed data type. This is also known as signed char. This is also known as signed int. This is also known as signed long int. This is also known as signed long int. So their values is still the same thing when you talk about what is the size of a signed float and what is the size of a signed long int on a 32-bit machine. The same answer that you need is the same answer that is here, which is 8 bytes. So because they did not specify that probably sign char, sign this, it does not mean, what you just need to know that as long as they did not specify on sign, it is signed. So when they now specify unsigned, then that means you will know that it is an unsigned. But when a particular sign specification is not given, then you will know that it is signed completely. You don't even need to put sign again. Just like saying plus 2 and 2. You already know that 2 is same thing as plus 2. You don't need to be adding the plus to it. But when you want to be specific, when you now say minus 2 is different from 2, because minus 2 is having a negative sign to it, and 2 itself is having a plus in an invisible positive sign in front of it. So that is that for this project, guys. Now this one looks somehow crazy, and that is where I actually did this man after what are they calling it, after the midnight. So in fact, I've not done today's task. So it said write a script that generates the assembly code in Intel syntax of a C code and save it in an output file. Let me even see how many persons are remaining. I'm happy. Oh. Please, let's be here till tomorrow. At least I'm seeing almost everyone. Let's be here till tomorrow. So it said write a script that generates the assembly code in Intel syntax of a C code and save it in an output file. So this looks technical a bit because now we have gone back to writing a script. Okay, we are now, this is not a C program now, a script. And what is the script going to do? It's going to generate an assembly code, but this time around it should be in Intel syntax. So that means there is a particular operator, there's a particular flag that is needed to be added to the GCC compiler, which will what? Which will generate an assembly code in Intel syntax. Aside the fact that there will be a flag that I'm going to add to it, the usual flag that will print an assembly code, and then there should also be a syntax for me to specify that it should come, the output should be in Intel syntax. The output should be in Intel syntax. So some people they don't call it syntax, they call it dialect too. Okay. And syntax, like I said, is just like the necessary letters and alphabet and symbols that are used to communicate. When you talk about syntax in programming language, the symbols, the letters and characters and tokens, all that are acceptable, all the acceptable symbols, characters, and letters in a particular what programming language. So those are what we call syntax. In our last class, I explained what is syntax. So now the very first step is to actually check the manual of the GCC file and see where we can see anything that has to do with generating um, assembly code in Intel syntax or dialect. So if I do man GCC, I'm using this very first search page. Remember I said we are actually we want to be specific about what we are searching for. So I want to probably search for assembly code, assembly code. So probably I see this search. This is telling me that there are 12 matches for assembly code. So let me start checking them one by one. So on the search, let me enter for, let me see this very first um, results. It's saying this option F verbose hyphen ASM, it puts extra commentary information in the generated assembly code to make it more readable. This option is generally only for use to those who actually need to read the generated. I don't want this, so let me check for another search. GCC name to determine what kind of instructions it can emit when generating. Okay, I don't want this. Let's see another one. So this one is coming from this flag minus hyphen mcpu equals name. It says specify the name of the target processor, optionally suffixed by one or more features modifier. This option has the form m minus mcpu cp equals cpu plus no C, no feature where with this pointer symbol where the permissible values for CPU, blah blah blah. I don't need this. I think this is not what we are looking for. I can't even find Intel here. So we are looking for something that will give me Intel. The following options control how the assembly code is annotated. Let's see. I want assembly code. This one is saying match equals name. Can I find anything like Intel here? Okay, this one specify the name of the target ARM architecture. When generating assembly code, this option can be used in conjunction. Okay, this is not what we are looking for. Mm. Now, we have checked everything. This is 11, 12, and there is nothing like what we are looking for. Let's now look for Intel. This one now might be too much. Intel is having 52 matches. So now let's see. Intel, no flag here. Intel i36, i386 Intel, i586 Intel. There's nothing like, it's not flag. We are looking for where the flag will be, and okay, okay, flag Intel. Now look at this. This is a flag. It said MASM equals dialect. Output assembly instruction. Okay, using selected dialect. Also affect which dialect. Also, it affects which dialect is used for basic ASM and extended ASM. Now, supported choices in dialect order are ATT or Intel. Now, what this is actually the answer we are looking for. This hyphen MASM equals dialect is now the option for the compiler that we are looking for. Now, this dialect is the syntax that we are talking about, like this what did they talk here say here, sorry, this one here saying write a script that generates the assembly code in Intel syntax. So in Intel dialect, that is what they mean. So, and to use this option or this flag, you have this man hyphen MASM equals what dialect Intel. So that is what we are talking about. Or if they said ATT dialect, then you put ATT. Okay. So that is just like the way to get the answer to what will be generated when you what when you run the compiler, as it's going to generate an assembly code. So in Intel syntax. So as usual, there will be this variable, of course, and then the output file should be named as the C file. This one are like the as usual stuff, but this time with the extension .s because we are working with what? An assembly code. We want to generate an assembly code. And so if the C file main.c as usual, this one. So we have passed through this stage. There's no need of like going. The only thing that we need to check now is that the output that will be generated, which is main.s, we need to make sure that it is similar to this or exactly like this. So when we generated, this is what should be like the output we should have. So if I open my file, which is the script is going to be 100 Intel. So if I say 100 Intel, if I vi 100 Intel, so the required syntax should be GCC generate an assembly code that is flag minus s, and then it should be in Intel dialect or Intel syntax, which is this. So this flag is for generating assembly code based on a particular processor. Is it processor or machine architecture? So this time around we are what is for Intel. If it is for ATT or any other thing, it's going to be equals to that dialect or equals to that syntax, that processor or that architecture, and then referencing the C file. So this time around, we are not even specifying an output name, but it will give it automatically the same name as what is inside this variable, and it is going to save it as .s automatically because it is an assembly code. So that is 100 Intel. That's the name of the file. Now, if I remove main.s and I run the script after doing chmod and all that, and I run the script 100 Intel, so it should create a file called main.s for me. So if I ls, of course, I have main.s. Now, another way of on the last step to checking your code if you are correct is doing the cars.main.s to see what is inside. And yes, it is as the same as what is on the output on the instruction screen. You have file main.c Intel syntax, no prefix. You could see it. So just like what you have here. File main.c Intel syntax, no prefix, dot text global main type, blah 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 function. And you won't forget you need to have your file main.c, which is going to contain. Of course, we have been doing that from the top. So that is about this number 7. Now the last one, number 8. You see this one, obviously it took me time. I couldn't get it. And I actually just tried something from my head, not my head, based on understanding about something I'm going to explain in a minute. So I just tried a particular code and it really worked. After which I didn't trust my code before I checked it. Before the checker gave me the result, because I ran my checker at that point. There's something that at every 4 o'clock, once it is 4 a.m. in the morning, the checker, if you try to check your code at that point, it will not give you response. It will be slow. It will just be rolling, so you won't get any feedback. So till it gets to 6 p.m. before it will now start working properly. So when I ran the checker on what I did, it was just rolling and I couldn't believe the answer. I just had to go and check for the answer on a particular resource, and I don't even know what really they did. So what did I do? Okay, to cut all the long story short. Now, this program is saying write a C program that is going to print exactly, and that piece of art is useful with this Dora Copper 2015 blah blah blah, followed by a new line. Now, it is now saying to standard error. Now they now say something that you are not allowed to use any function listed in the name section of man 3 of printf or man 3 of puts. Your program should return 1. This is where the answer actually is, because sometimes you would be like, since they don't want you to use, we am coming to these guys in a jiffy. Since they don't want us to use any of these guys, then they said my program should return 1. That means I can just do printf and put this thing inside, and then my instead of my return inside my main function should be 0, my return should just be 1, and that is just my answer. And he said your program should compile without any warnings when using the war gcc, of course. So that should have just been the answer. Now this line here, what is printf man 3 and man 3 puts? Now there is a printf that's that's that caters for errors, and it prints the errors that it gets to standard error, okay, instead of to the screen. Like, if and that printf is actually f printf. If I do man printf 3, okay, so if I do man printf 3 and you check under the man printf 3, there are other options. We have the printf and we have the f printf. This is actually what we are looking for. Now if I search f printf, now it said f printf, this manual page is part of the blah blah blah. Now what does this fprintf do? The fprintf function shall place outputs on the named output stream. The printf function shall place output on the standard output stream. Now, no, fprintf, what does it do actually? It is used for printing the standard error. Okay, so technically, if I'm to do that project, all I just have to do is just to do fprintf, then the string fprintf. Then what I'm to do next is a there is this command or syntax called std error, standard error, comma, then the text followed by a new line. So what this will do is that whatever it is inside here, it's going to print to the standard error instead of. So that is what this fprintf does. But they don't want us to use it. For example, if I do fprintf usage, if you look at this part here, okay, printing with fprintf is standard error. So if you see, now look at what they did here, the syntax generated here. We have int main fprintf, then the standard error command, and then this is an error message. This is what will be, this string will be printed to this standard error, and it will always return. Yes, yeah, this is just the main program which will return successfully, but when you run this, it is going to return it to the standard error and return an error value. So basically the answer is just to do, let me open it, vi101 quote dot c. This is what I did here actually, but Let me create a copy of it. VI one, I mean CP 101, and I put it into 101 code. Let's see. And I VI 101 quotes. Let's see. So what is to be done, you can just get over this guy. Don't need this. What is to be done is just the printf this string, and what we need to do is actually to return one, because according to the instruction your program should return one. So the target is just for our program to return one. All this English here is something that's made it somehow complex. Of course, there is a medium to print it to the standard error using fprintf and or fputs. So when you do it this way and you return one, it is just telling you that your program did not um, return well, did not run successfully, that is, it failed, no, no success, or does not run successfully. And when you when you do git add and git push it, or commit and push, you will get your answer. So this one is like a technical something that is, I don't have deep understanding about it here, but to get the answer is just to make sure that you return one. Okay, guys. How many people still remember? Wow. Can we continue? Can we move? Wait, I saw a message here. Abisola has gone. Good night, guys. She's still here. Oh. Don't go anywhere. Guys, can I don't know if this is possible. This is what we have for our lesson. Um, from this place. Oops. What should we do, guys? Should we continue? I want to get everyone's response, and then aside that, I should get evaluation from us. What's the is there any observation, question or something? I'm going to stop this live stream.